Today you have 2 pencils. Yesterday you didn't even have 1. You're doing well. Okay. So we're going to talk about the distributive property again today, not dilations. Let me get that off there. Okay. So we've been using the distributive property, and I think we've even done problems like this. Isn't that correct? Where we said, okay, 2 times x times 2 times y is 4 times x times y. And 2 times x times 8, that would be 2 times 8 is 16 times x. So we never actually multiply by x, we just say we're going to eventually when we figure out what x is, or at some point, right? Okay, and so we end up with this right there. And I think we've been doing some other problems where we had something like x times y cubed times x squared times y times x, and we had to simplify. Now let's see, how many terms do I have here? 1. Let's count them. 1. Good job. Okay. So what's x times x squared times x? X to the 4th. And what is y cubed times y to the 1st? Y to the 4th. Okay. Well, what we're going to do today is we're going to put those 2 types of problems together into one problem. And it's not really going to be a big deal for you. In fact, I wonder, even if I didn't mention it, if I just started giving you this problem, if you would have figured it out yourself. So remember, the rules don't change. Okay, when we multiply, we add the exponents, right? And with the distributive property, we're still going to do that same thing we always do. We're going to go x times y squared. So we literally have x times y squared. And then we're going to say x times y times x squared times z. Negative x squared times z. So negative x times y times x squared times z. Can we write that in a more simple way? I heard a yes. How?
X, y, 3.
Okay, so x, y to the 3rd. So we can multiply these y's together, can't we?
Yeah.
And then subtract. What about these x?
Cubed, y, z.
Yeah. And let's be honest with you, we never write that part. We just do it. Okay? We just do the problem. So here's another example of this. 4xy cubed times the quantity x to the 4th y, subtract 5x. And when I say times the quantity, I mean the next thing I'm going to say is in parentheses, and the entire thing has to be multiplied. That's what I'm always talking about. Okay? Thomas, paying attention? So, here we go. Ready? 4 times what? Times what? Times what? Isn't the coefficient there 1? Okay, so we are literally going 4 times 1 is 4. What about x to the 1st times x to the 4th? Okay. How about y cubed times y? Y to the 4th. Okay. And then we're gonna multiply the second term. 4 times negative 5. And what about x times x?
X squared.
Okay. And now we still have to take y cubed times this last term as well. So it's still y cubed over here too, times y cubed. We see another one? Here. Let's do this one a little bit different. Times the term here, 2x squared y. Normally we put this term out in front, and we could at this point, but it doesn't matter. But we're still going to do it in the same order. We're still going to multiply the first term in the parenthesis first, and then we're going to multiply the second term second. So 2 times what?
1.
How come I'm not hearing from you guys? 2 times what?
1.
There you go. That's 2. And then we've got times a and then x squared times this, that's just x squared.
And then y squared.
Yeah, y times y is y squared.
Yeah.
Getting it?
Yep.
Okay. And then 2 times
-4.
-4, that's -8. And then x squared times it, that's x squared. And y times y to the 5th, and y to the 6th. So we're just adding those together. So, I don't know, does this look much better than what we started with? Is it simpler? It is, and there's a big, big difference between this, and that is no parentheses. Getting rid of the parentheses is a big deal. Right? What's the first step in solving an equation? Get rid of the parentheses. Okay, so we got to do this. P.S. Remember in elementary you learned to add, then you learned to subtract. You learned to times, then you learned to divide. You learned about exponents and roots, didn't you? Soon, I'm going to give you this, and you're going to have to go backward to here. Yeah. Fun. You'll do it. It'll be easy. Here, let me give you an easy one. Here, you guys all do this one on your paper where you're going to do set 27 today. 4a times 3a times b subtract 6a. Hey, cover your nose up. Thank you. Are you writing down the original problem on this one or just the answer?
Just the answer.
I just write down the answer on this one. Yeah. Okay. Can we add those two terms together in the parenthesis? I see you shaking your heads. Why not? Yeah, they're not like terms. Okay. But can we multiply even if they're not like terms? We can multiply anything. So 4 times 3. Did you say a times a is a squared? And then also times b. 4 times -6. And then what's a times a? A squared. There we have it. Pretty simple, isn't it? So we're just taking a couple things you already know, putting them together into one problem, and that's mostly what we're going to do the rest of the year. Okay, yesterday we talked about a decimal equation, or an equation with decimals in it, and I showed you how to get rid of the decimals and not have to worry about them till the end. So we can solve this problem. Why do I have a time sign there? Plus. Should I rewrite that? Sorry about that. Plus 0.02 times m equals 4.6. Okay, we can just solve this like normal. No parentheses, no like terms, no variable on both sides. What's got to go right now? Okay, so we're going to subtract 0.4 from both sides. Now I'm just careful about the way I do this. I'm going to line up my decimals, and that's pretty easy, 4.2. And then we just have to divide both sides of the equation by 0.02. Now I know 42 divided by 2 is 21. But I'm not real positive about where that decimal is when it's 4.2 divided by 0.02. Getting the decimal in the right place is a little iffy, because this could be 210. It could be 2.1. What do you guys think? You think it's 2.1? Should we try it with a calculator? See what the calculator says? 4.1 divided by 0.02. Now remember, 0.02, that's a pretty small number. 2 hundredths? Yeah?
Mr. Collar,
So,
isn't it 4.2?
What do we get?
That's 4.2.
205?
It's 4.2.
Sorry, I didn't put it in. Did I put 4.02?
They put 4.1.
Oh, did I? Oh, yeah, that's what it must have been. 4.2 divided by 0.02. I can't see what I'm typing. I can't see the screen there. That better? How is it 210?
That's a big number.
Because 0.02 is very small.
It is. 0.02 is very small, and it's the same as taking 420 and dividing it by 2. Think about if we set it up here. 4.2 divided by 0.02. Don't we have to multiply this by 100 to get the decimal over? We have to move the decimal over. We have to move this one over 1, 2 times. Now we divide, don't we? Okay? And just dealing with decimals in general can be a little bit challenging. I'm going to show you a little trick here. Plus this time. If you don't like dealing with the decimals, we can get rid of them right now. Okay.
Can we like times it in?
Yeah, we can multiply both sides of the equation by 10, or by 100, or by 1,000. Okay, as long as we multiply both sides of the equation by that amount, the new equation will be equivalent, right? Tyler, now's not the time. Pay attention, okay? So, I don't know, what do we need to multiply here by to make all of these decimal numbers whole numbers? Like, would 10 do it?
No, it's gotta be 100.
Well, 10 would do it here, 10 would do it here.
Not,
Not there?
yeah, it's gotta be 100.
Okay, so we're going to multiply both sides of the equation by 100. And what that boils down to is you need to multiply every term on both sides of the equation by 100 in order to keep it equal. See, so see how I'm going to use the distributive property here? What am I going to get when I multiply by 100 here? Yeah, I just moved the decimal twice. See, 2 decimals. Over here, 2m. And here,
460.
there you go. Now this new equation, it's not the same equation, but it's equivalent. And that means it has the same solution, or the same root. So now when I go to solve it, see, I get the same solution, but I didn't have to deal with the decimal so much, did I? Okay. Now I don't know if that's a whole lot easier, but something good to know. We do use it sometimes. Take a look at this problem. What would we have to multiply every term by here?
1,000.
1,000? Why 1,000?
Because there's
There's
zeros
no
and
coefficients.
zeros.
Yeah, we got to move that decimal 3 places, don't we?
Yeah.
So that's what we're going to do. We're going to multiply every term on both sides of the equation. We're going to multiply by 1,000. Okay? So what does that give us right here? 2k plus, now look, 1, 2, 3, 20. And over here, 1, 2, 3.
4,000.
Yeah, 4,020. So now this is an equation we can solve. It's going to have the same solution, same root. We can just one times k. There it is. Do you think that's easier to get rid of the decimals and then do this, or just do it with the decimals in it? Should we vote? Who thinks it's easier just to do it with the decimals in there?
Do we have a calculator or no?
You do have a calculator.
It's easier with that.
Okay. Who says no, get rid of the decimals and then solve it? About half and half. Okay. Yeah, do you have a calculator? Can you use a calculator? Sure. Okay. I've even got some up here you can borrow. You remember to put them back. Okay. But But, okay, this is a big but. Calculator doesn't mean you just type it in the calculator and write some answer down on your paper without showing me the work, right? Calculator means like you get to the and maybe that's a hard one. You can use the calculator for that. But if I see you using the calculator to divide 4,000 by 2, I'm probably going to blow a gasket or something. You know that vein in my forehead that pops out when I go crazy sometimes? Don't do that. You know, just use it when you have to. If you still feel like you're just horrible at fractions, use a calculator to help yourself out, okay? But try to keep it as minimal as possible. Now, I'm not going to tell you after today that you have to use this method and get rid of the decimals. It's really a choice. Every time you see an equation, is it worth it or not, okay? But today we are going to practice doing this. So on page 115, see practice F. Once you guys do that one, and I'll just walk around and help you. Oop. Practice F. And I do want you to eliminate all of the decimals before you solve the problem. So let's start off doing that. Can we get rid of the decimals first and then go through our steps? Remember, think through your steps. This problem's going to be really hard if you don't think about the steps in order. Oh, that's an M, isn't it? 0.7 M. Oh, crap. Yeah. What'd you have to multiply everything by?
10.
10? Okay. So we multiply everything by 10. That's pretty simple. We end up with 7m plus 6m. So you guys are multiplying this entire side of the equation by 10, right? You multiply it over here by 10 equals 34.
Oh, I put 340.
Oh, yeah, we got to do the same thing on both sides. Now, there are no now we go to solve the problem, right? There's no parentheses, yay. Are there like terms? Yes. We've got to put our like terms together now. Now, do we have the variable on both sides? No. Do we have a constant we need to get rid of? No. All we have to do is reduce this coefficient down, right? Now, it should come as no big shock to you that our answer is going to be a decimal number. When you have decimals in the original problem, your answer is probably not going to be an integer. It's probably going to be some kind of decimal fraction. And we don't want to give our answer as 34/13 because the original problem had decimals in it. If the original problem has decimals in it, give a decimal answer. If the original problem has fractions in it or whole numbers, then it's more okay to give a fractional answer. Okay? So we are, at this point, yeah, get out a calculator. Get out a calculator. 34 divided by 13.
Maybe 2 point something.
It is.
2.3.
How do you want to round that off?
2.6.
2.6? I'm going to say 2.62.
Alright.
Let's round to the hundredth. So 2 decimals or to the hundredths place. Does that make sense? Okay, so that's normally how we do it. So 2.62, and I might even say that's the approximate answer. But don't be surprised when you get a decimal answer like that when you have decimals in the first place. Just put it in your backpack, then that won't happen. There we go. Okay. It's Friday. You got time to do this in class. No homework this weekend. Let's go. You've got to put your mask over your nose. Got to.